Along with that, temperature, number of moles are there, temperature is there, temperature is there, number of moles, generally define states of a system. Right. Now let us take some example. Name of the system, here I am taking name of a state and a condition I am taking here, as well as special aspects also we are going to take. Name of a system, first one, a name of a isothermal state, right? Isothermal state. It is commonly represented or condition delta T is equal to delta is the symbol which represents the state, whether it is isothermal or etc. And it is define the enthalpy rate also. Delta T equal to 0, delta U equal to 0, delta H is equal to 0. These are should be satisfied. Okay. If delta T is equal to 0, what will happen? Exchange of heat between a system and surrounding takes place. So in this case, special aspects are exchange of heat. Whatever heat energy produced, it is going to be exchanged with the surrounding environment. If delta U equal to 0, right, B, right, you know, Q system, Q system, right, is greater than 0 equal to uh, greater than 0, that implies process is an endothermic process. This is commonly endothermic process. If you take delta H, that is C, Q system, Q system is less than 0, that is commonly going to be implies process is an exothermic process. What is that called? Exothermic process. Now, if you take the D option, right, work done, work done equal to, and it is represented by W, right, minus P, and it is present in the already existence is there. And if we take work done and V1 minus V I or VF minus VI, right? And along with that, the process is irreversible. The equation is commonly used if the process is irreversible, right? Can't be reversed once again, once if it is done. If you take E, work done, W equal to, so minus N capital R T. Now, in detail, what is N, what is R, I'll discuss with you in the next video. And if you carefully see here, Vf minus uh, Vi, which is a formula that implies the equation is used if the equation is reversible. Very, very important, these all equations. Try to be aware of it. After that, if you take the F, one more uh, special aspect, Q is equal to minus W. W, since as you know that since it is delta U equal to 0, right? Now we will take one more uh, thing, that is adiabatic, right? Adiabatic, commonly adiabatic form of, and it will be Q equal to 0. Special aspects are, if I take a special aspect A, temperature of system rises in exothermic. Temperature is going to rise in exothermic reaction. Know the difference between exothermic and endothermic process. And decreases in endothermic process. it is going to be decreases, right? Symbol for decreases in a endothermic process, right? So as well as work done, if you want to know how work is done, work done indicated by W equal to delta U. Next, isobaric. Third one is isobaric. What is exactly isobaric? When delta P is equal to 0, then special aspect will be volume, it is going to be changed. The volume is going to be changes. Example, what is the example for it? 2H2, 2H2 grams plus O2 is there. It is also there in the grams, right? And also 2H2 is there, and isobaric in condition. Delta V here in this case, it is generally greater than 0. Why? Because if the delta is greater than 0, then only it is going to increases in the reaction. That is the reason why it is mentioned like that. Next one, isochoric type. Let us take a fourth one, isochoric type of system, right? Name delta V equal to 0, and pressure changes, special aspect, pressure is going to be changed, or pressure changes, as well as example here, a reaction I would like to take, N2O4, right? It is there in the gas state, and when it is reacted, it will produce nitrogen dioxide, which are in the gas state, which finally implies delta P here is commonly less than 0. Okay. Fifth one. Next, reversible. Exactly, we have to know what is reversible type of reaction or a system. The system is almost in the state of equilibrium, of course, very slowly. So, a reversible system, it is constant equilibrium, but slowly it is going to happen, occurs. Work done is maximum under isothermal reversible process, but work done under adiabatic, right, or reversible manner. Now, in this case, what is a formula that we uses? W work done equal to NR into T2 minus T1 by, right, CP value. Here we have to take. I already told you what is CP value. I'm going to make another video upon it. Don't worry. CP under CV minus 1, right? Or it is also represented as NCV into T2 minus T1. Therefore, as you know that since Cp minus Cv equal to R, you can write the same equation like this also. Next system, irreversible system. Sixth one is irreversible system. Once reaction is done, it can't be reversed once again. The system is not under the state of equilibrium occurs rather than quickly. Work done is work done is minimum under isothermal adiabatic condition. So isothermal adiabatic condition is commonly observed in irreversible reaction. W equal to minus P, right? And EXT represents exothermal reaction. EXT exothermal reaction, and delta V also going to be taken. This is along with that cyclic state. What is exactly a cyclic state of reaction? Cyclic state, it is nothing but delta U or delta H equal to 0 or delta S is equal to 0, right? Now, in this case, at constant level, state aspects at a constant